Hello friends, welcome to Physics Live channel. Today we are going to study the applications in vector calculus. Applications of gradient, that we can find the normal vector by taking gradient of the vector del phi is equal to n bar. Del phi is equal to vector, that is a normal vector. Unit normal vector n cap is equal to del phi divided by mod del phi, that is n bar divided by mod n bar. Another application, that is angle between two surfaces. The surface phi1 and phi2 are given and their normal vectors n1 and n2 are del phi1 and del phi2. So angle between two surfaces, that is cos theta is equal to n1 bar dot n2 bar divided by mod n1 into mod n2. Directional derivative. The directional derivative is the rate of change of a function in any arbitrary direction is called directional derivative. Where the function is given by phi and the direction a cap. So del phi dot a cap will give the directional derivative. A cap is a bar divided by mod a. Equation of tangent plane. A surface phi is given. We have to find the equation of tangent plane to the surface. The equation is r bar minus r naught bar into del phi equal to 0. Where phi is the surface, del phi is the normal vector to the surface, and r is a arbitrary point, r naught is a given point, dot del phi equal to 0. This is the equation of tangent plane. Another representation, that is x minus x naught x cap plus y minus y naught y cap plus z minus z naught z cap dot del phi equal to 0. Laplacian operator del square phi is del dot del phi. Cartesian, that is del square is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Cylindrical coordinate system, del square is 1 by rho dou by dou rho dou by dou rho plus 1 by rho square dou square by dou phi square plus dou square by dou z square. Spherical, del square is equal to 1 by r square dou by dou r square dou by dou r plus 1 by r square sin theta dou by dou theta sin theta dou by dou theta plus 1 by r square sin square theta dou square by dou phi square. We should by heart this formula so we can find any Laplacian for any coordinate system. In physics, we know that we have to find gradient, divergence and curl of functions. It is important that we have to find these operations for a radial form. So we have to find radial form, gradient, curl and divergence also. So radial forms f of r or f of r cap. Gradient of radial form, we know that del bar in spherical coordinate system, that is r cap dou by dou r plus theta cap by r dou by dou theta plus phi cap by r sin theta dou by dou phi. Radial form, that is a function which is only depends on r. So we know that the gradient is changes as r cap dou by dou r f of r. The next two terms are 0. So we have to consider only the first term. So radial form gradient, only we consider the equation r cap dou by dou r f of r. That is derivative of the function. We know also now that gradient of a function which give you a vector. So we have to represent r cap. Del of mod r is dou by dou r of mod r is 1 and r cap is the answer. Del of r square, we have to just derivative with respect to r for the radial form. This is the equation. So r square derivative is 2r r cap. R cap, from this equation r cap is equal to r bar divided by mod r. For r bar is equal to r cap. So r cap is replaced with the r bar So 2 r bar. Del of 1 by r is minus 1 by r square r cap, because we know that the gradient of radial form is the just derivative of the function. So minus 1 by r square r cap. Next, divergence of radial vector. We know that divergence of a vector which give you a scalar only. So in spherical coordinate system, we know that equation of divergence, that is 1 by r square sin theta dou by dou r r square sin theta plus dou by dou theta a theta r sin theta plus dou by dou phi a phi r, in which dou by dou theta, in which theta and phi dependent components is not exist here, only r dependent term only exists, that is radial vector only. So this term only exists, that is 1 by r square sin theta dou by dou r f of r square sin theta, where sin theta is a constant with respect to dou by dou r, so it take outside and cancel sin theta. So 1 by r square dou by dou r f of r square. We know that it is a product u into v derivative, that is u into derivative of v plus v into derivative of u, like that 1 by r square is exist here. So 1 by r square dou by dou r of r square is 2r into f of r plus r square into dou by dou r of f of r. From that 1 by r square take inside, that is 2 by r f of r plus dou f by dou r, that is a divergence of a radial vector which can be found by this formula. It is very useful, that is del bar dot f of r cap, that is equal to 2 by r f of r plus dou f by dou r. Here one example, we have to find the divergence of r raised to n r cap. We know the general formula, that is 2 by r f of r plus dou f by dou r. Here the function is r raised to n. So 2 by r raised to n plus derivative of f with respect to r. That means f was r raised to n, that is n r raised to n minus 1. Here r and r cancel, so 2 r raised to n minus 1 plus n r raised to n minus 1. R raised to n minus 1 is common, so n plus 2 r raised to n minus 1 is the answer. So we can find any divergence of the radial vector, find from this formula, that is 2 by r f of r plus dou f by dou r. Curl of a radial vector, we can find curl of f of r cap from the spherical formula, that is r cap r theta cap r sin theta phi cap dou by dou r dou by dou theta dou by dou phi f of r. It is not exist here because f of theta and f of phi is not exist here. So we can find the determinant of this function as r cap into dou by dou theta into 0, dou by dou phi into 0, so 0 only, r theta cap into dou by dou r into 0, dou by dou phi of f of r is also 0, and r sin theta phi cap of dou by dou r of 0, dou by dou theta of f of r is also 0. So we can find that del cross of f of r cap is 0, that is radial vector curl is 0. You know that curl is 0 means irrotational. So consider the equation, that is del bar cross r bar is equal to 0 only. So we have to remember the three equations, that is the gradient of a radial vector is the differentiation of the function with respect to r, and the divergence of radial vector is equation is 2 by r f of r plus dou f by dou r, and curl of a radial vector is 0. Thank you for watching.